Hello guys, we are going to solve today's lead code 1339 maximum product of splitted binary tree. Yeah, here they have given like one sort of a binary tree and they just uh, must cut the exactly one edge and this splits into the tree into the two subtrees. And here we need to find the maximum product of the two subtrees. Like they have taken one sort of binary tree and they simply exactly cut the binary tree into two parts and they just made the sum of those two parts and they just product the sum of those two uh, subtrees. So we need to return the maximum sum of maximum product of the trees. So for that we are going to follow for this problem we need to find the total sum of the all the nodes and we need to try every possible split and calculate the product. So for that I am going to code now. So for that I am considering one sort of total variable. I'm taking total sum. By default it should be start with 0. So self node, so total sum is equals to 0. I'm initializing it. This variable stores the all the sum. It will store the sum of all the nodes and we are going to calculate the subtree sum. So for that I'm considering one sort of function like def get total sum. I'm passing the node. Each node should be calculate right, iterate right. So for that, if the node is empty means we'll simply return the sum should be 0. If not node means we'll simply return it 0. If it is having a nodes, if it is having the nodes at the left or right, then we need to append into the left and right variable. So for that, I'm considering the recursively get left and right subtree sum. So for that, I'm considering variables and get total sum node dot left. We need to append each and we need to iterate each and every left nodes in the tree recursively. So for that I'm doing, and for same as for the right operator, right subtree. So total sum should be node dot right. Now we are going to add the current node value to the total sum. So for that current node should be like we need to consider total sum is there, right? Self dot total sum, and we need to add every node value here increment. After adding current node to the total sum we simply return this function. So for that return each and every node dot value root and left and right as well. It shows that it returns the sum of the current subtrees. So for that we need to make an call. Now it starts calculating from root onwards and to the total sum of the tree. So for that right now I'm just calling it with the total get total sum of root. From root onwards it will just iterate to the top to bottom. Now this is the second step. Here we need to try every possible split of the tree. So for that I'm considering one self dot max product. Consider it will stores the maximum product found. Like I'm going to take def of by using dfs. I'm going each and every node from top to bottom by level. So dfs travels to calculate the subtree sums. So if not node means I will simply return it as a 0. Return 0. Up to like node should be empty. Like, and otherwise like we need to take same as like dfs of node dot left, and same for the right subtree as well, node dot right. Now we are getting like we are getting left and right subtree sum as well. Now we need to know the sum of the current subtree. So for that subtree sum is equals to node dot value plus left plus right. And one of the subtree sum is equals to like a subtree sum, and other subtree sum should be like a total sum minus subtree sum. So for that we need to calculate the product value. So we are going to take the product as like subtree sum into uh, self dot, because it is at the top, right? So we are using self and dot sum minus subtree sum. After that, like, we need to update the maximum product, like self dot max product is equals to max of self dot max product comma product. And after updating the maximum product, we need to return our subtotal subtree sum to the parent element. So we need to return the subtree sum, and we need to make a call of a DFS of root, and as well we are going to take in modulo, because to avoid the overflow of large set of values, we need to use modulo functions. So for that I'm going to take modulo return self dot max product of mod. Here, like, we need to take the mod as like, we need to initialize the size mod equals to 10 power 9 plus 7. Yeah. Now we are going to test the normal test cases. Here max product is not defined. Let me check. Yeah, here itself we need to use self, right? Self dot instead of comma. Again we need to test for the normal test cases. Yeah, it is accepted. Now we are going to submit the code and test for the hidden test cases. Yeah, it is pass. For this, time complexity should be big O of n. Each node visited twice, right? So time complexity should be big O of n, and the space complex should be a big O of h, because recursively stack, right? This one, h should be the stack of the tree. Yeah, here simply, like, we can say that first we follow the DFS to get the total sum, and yeah, DFS to get the total sum, and second DFS, like, try to cut the each and every sub part of the tree, and then we have track in the like maximum product, and we'll simply return the result in the form of the modulo here. Yeah, we are going to submit, and thank you so much.